standard form for quadratic function, f of x equals ax squared plus bx plus c. A quadratic function is also a polynomial function. We call it a polynomial of order 2 or of degree 2. And polynomials in general have positive integer exponents. And the order or degree is always the power on the highest power on the variable, which would be x squared, so that's why it's a polynomial of order 2. Now that x squared term tells us a lot. If a is positive, the graph is a parabola that opens up. If a is negative, the graph is a parabola that opens down. So that our parabola that opens up, the lowest point is called the vertex. And since it is the lowest point, it's also called the minimum. A parabola that opens down, that's where the vertex is, and it is the highest point. Or the maximum. The first term, ax squared, also gives us information about the end behavior. The end behavior really is just what the ends of the function are doing. And it only happens with the x squared term because the end behavior happens as the x's get very large, either negative or positive. If I have a very large positive number and I plug it in, the x squared is so much bigger than the bx plus c part, if x is a very large number, so that this ax squared term gives us the end behavior and is called the dominant term. When I have a very large positive and a is positive, the numbers get bigger and bigger. If I have a very large negative number for x and I square it when a is positive, it's still positive, so it gets bigger and bigger. So if it opens up, the end behavior from the dominant term means the ends are getting higher, larger numbers. If a is negative, I put in a value for x that's a very large positive number. I square it, but because the a is negative, I get a very large negative number. And if x is a large negative number, and I plug it in for x and square it, if a is negative, I still get a very large negative number. So we can say that as x approaches either positive or negative infinity, that gives us y values. If a is positive, y approaches a positive number for whichever direction x goes, positive, infinity, or negative. And if a is negative, the y values approach a negative, very large number. We say negative infinity. And that's what we call the end behavior of our function. Let's look at how we can figure out exactly what the vertex is with a particular problem. Now we'll look about finding the vertex precisely. from the formula, f of x equals ax squared plus bx plus c. The x value of the vertex can be found by taking the negative of b over 2 times a, using the b that is the coefficient of the x term and a that is the coefficient of the x squared term. To find the y value, that's f of x, so plug in x. After you find x, you plug it back into the function to find the y value of the vertex. So let's look at finding the vertex of a particular function. R of q equals negative 1/3 q squared minus plus 4q minus 2. Negative 1/3 is our a value multiplied times x squared, in this case q squared. B is plus 4. And the c doesn't have any bearing on the x coordinate or the q coordinate. So whereas before x equals negative b over 2a, my variable is q. So q equals negative of 4 over 2 times a, which is negative 1/3. So I have negative 4 over a negative 2/3. The two negatives means it's going to be positive. So I have 4 times, and when you divide by a fraction, you invert and multiply. 12 halves is 6. My x coordinate is 6. To find the y coordinate of the vertex, I plug it back in place of q. So every place there's a q, I put a 6. Negative 1/3 times 6 squared, which is 36, plus 4 times 6, minus 2. 1/3 of 36 is 12, so that gives me negative 12 plus 24 minus 2, which gives me 10. So the vertex here is equal to the point where x is 6 and y is 10, or q is 6 and r is 10. Horizontal axis would be the q because that's the input into the parenthesis. The vertical axis is r. I have a negative value for a, which means my parabola will open down. My vertex is at 6, 10. Let's call that 6. We'll call this 10. My vertex is here, and the graph will open down. Now, instead of just drawing a graph, let's check one more point. Always you want to check the intercept. Let q equal 0, and we get r equals negative 2, so it goes through negative 2, say about here. And then it goes down again. Not very neat, but that's a parabola. So it opens down. Now, the domain, the numbers that I can plug in for q, can be all real numbers. This is a polynomial. I can plug in q. I don't have any problems. All reals. The issue would come if I had a q in the denominator or a radical. For the range values, those are the y values, the function values. And looking at the graph, my function values all are below 10. The function values are where the graph is. So my range is y, or f of x, less than 10. If I want to find r equal to 12, that's not going to happen here because that value is not in the range of this function.